Hello everyone, welcome back to lesson 33 for BC Calculus. We're talking about integration by parts. In the first video we did three pretty simple basic examples, and we're going to continue on with some more basic ones in this video right here. So example number 4, as you guys can see, is trying to integrate x sine of 3x dx. So with the iLate, we can see that we have an algebraic function and we have a trig function. So we're going to remember that the u in our example is going to be what's the closest one to the top, or to the left, I should say. So ILA comes first. So x is going to be our u. And then our dv is going to be, go ahead and write this out for us. Our dv is going to be everything else that we see here. So it's going to be sine of 3x dx. So find du is actually very simple. It's just a derivative of x, which is 1 dx. If we want to integrate, because remember v is going to be the integration of sine of 3x dx. Now this again is not very complicated. We've done it many times before, but you do have to use a u substitution for this problem, where you have to use u is equal to 3x, du is going to be equal to 3 dx, and so we have a 1/3 that we have to pull out of our function. So we're left with v is equal to the integration of 1/3 the sine of u du. So just be really careful that we do remember that the 1/3 is part of that. And so our v is actually going to be equal to 1/3, and then the integration of sine is going to be negative cosine. And then obviously we have to then plug in back what our u value is. So this is going to be negative 1/3 cosine of 3x. And so that's really the setup, if you will, to solve these particular problems. And then the integration of x sine of 3x dx is equal to. So this again is the u, and this is going to be the dv. This part right here is the dv. So the integration of u dv is going to be equal to u times v. So we're going to first of all do u times v. We're going to multiply these two things together. So we're going to get negative 1/3. I'm going to go ahead and plop the x down here, cosine of 3x. And then I'm going to minus, right? So this is u times, this is uv, minus the integration of v times du. So I'm going to integrate negative 1/3 cosine of 3x dx. Okay? And so what we can do, and I'm going to go ahead and simplify this in this particular step, is I'm going to go ahead and pull out the negative 1/3, which is going to make this a positive 1/3. So I'm going to do that now. So we can just say plus 1/3 with the integration of cosine of 3x dx. So now we have to integrate this. This is not hard to do, right? This is the rest of the part. We just have to integrate cosine of 3x. Well, just like in the previous thing right here, we're going to make u equal to 3x, and you guys get the whole issue that's going to be 1/3 du equals dx. So we have to pull out a 1/3. So let's just go ahead and write out that this piece here is negative 1/3 x cosine of 3x. I'm going to pull out a 1/3, and I have this 1/3, so this is going to end up being a 1/9. And then when I do that, I'm left with the cosine of u du here, right? Cosine of u du. Well, if you integrate cosine, you get back a positive sine of u. So this is going to be 1/9, and then it's going to be positive sine. Our u is going to be 3x. And then we're going to do plus c. So I know I flew through that very quickly, but my expectations is that if you're now looking at this video and we're talking about integration by parts, that you are really, really superstars at integration using U-sub, especially basic sine and cosine functions. So that's really all that you have to do for that problem. What I want to talk about next is this question. Oh, and by the way, in a video coming up, I'm going to show you guys a shortcut to how to do this problem, where if you have an algebraic function and then some other function, you can do a nice little shortcut. And so stay tuned to that. I'll do that one in probably the 4th video. All right, for example number 5, it says the natural log of x dx. Well, this is very interesting because students look at this and they don't actually see that this is integration by part. But we actually have two functions here. We have the natural log of x, and we actually have dx here, 1 dx. So if we remember iLate, then our u is going to be the log function, which is going to be the natural log of x. And then our dv is going to be everything left. Again, it's 1 dx, which is an algebraic function. So it's going to be 1 dx. And when we do the derivative of natural log of x, we're going to get 1 over x. If we integrate 1, we're going to get x. And so that's what we need to do for this problem. It actually becomes one of those easy, straightforward integration by parts problems. Because once we acknowledge that we have, u is the natural log of x and dv is dx, and we take the derivative here and integrate here, well, our integration by parts property tells us that u times v, which again is going to be x natural log of x, minus the integration of, and look what awesome thing happens here. It's going to be v times du, right? We always multiply these together, and then we multiply these together. So it's this times this. So it's going to be 1 over x. Again, I realized I did it in the first video. I'm doing it here now. We always want to write the dx down here. That's really important. So it's going to be 1/2 1 over x dx, which you guys can see clearly simplifies down to the integration of 1. So this is a really awesome problem. So x natural log of x, when we integrate 1, we get x, and we're going to do plus c. So if you were to actually go and take the derivative of this function right here, then and simplify, you're going to get the natural log of x back, which is actually pretty cool. So that's what we can do with that. So I'll give you guys one more example of a problem like this that you would not necessarily imagine as integration by parts. And then we're going to do in the next video how to do something where this is not easily integrated. All right, so I'm skipping over to example 13 where I'm asking you guys to integrate arc sine of dx. So in this particular example, again, we have two functions here. We have an arc sine, and we have, which again, use an isolate. That's obviously an inverse trig function, so that's clearly going to be our u. And the other thing I should actually say about this, and I probably should have said this at the very beginning of the first video, you want to make your u something that's harder to take it, so when you're doing u versus, so let me actually write this out first. So why do I want u to be my inverse trig function rather than an algebraic function? Because remember, all we're doing to u is actually taking the derivative. What our dv is, we actually have to integrate this. And so it would be silly for us to make dv arc sine because that's the problem we're asking to solve here. So it's easier to integrate an exponential function and a trigonometric function than it is to integrate an inverse trig function or a log function. So that's why when we do these problems, we want to make u equal to the one that's the furthest up. So this is going to be our arc sine. And then dv is simply going to be the dx. And so, just like I said prior to this, it's easy to integrate 1, right? 1 dx is simply just going to be x. And the derivative of arc sine is going to be 1 over the square root of 1 minus x squared dx. It's really easy for us to take the derivative of that. And so once we have all this information, then all we have to do is now actually write out the formula for our integration by parts. So again, we're going to multiply these two things together. So we're going to get x times the arc sine of x. I'm just going to write it like this for us. And then we're going to do minus the integration of this. So v all over, x all over the square root of 1 minus x squared dx. Now, I know this example is pretty, we're done with this multiple choice question, right? We know what the answer to this problem is. We know that the answer is actually D, but we can actually integrate this. We know how to integrate this. We can actually figure this all out because this is just another classic example of u substitution. So u sub, we're going to make, actually let's write over here. So u is going to be equal to 1 minus x squared. So let's just keep going with this problem. And that du is going to be equal to negative 2x dx. And that's why the x is setting right there. And remember, if the x wasn't here, then this would be another arc sine problem, right? So just be careful about what you see when you do the integration for this. So this is going to be negative 1/2 du is going to be equal to x dx. So our little side note is going to be, I'm going to just put it right here. So negative 1/2 is what we're pulling out. And we're going to be integrating du all over the square root of u. So again, this is our du, and then this is going to be the square root of u. So this is going to end up being 1/2, or negative 1/2, u to the negative 1/2 du. So I'm running out of room here, but I can go ahead and just somewhere here. So negative 1/2, whenever we integrate u to the negative 1/2, it's going to be u to the 1/2, which is going to then multiply by 2. And so these are going to cancel out. And so we're just left with negative square root of u. So this all simplifies down to negative square root of u. And again, if you're watching this video, my assumption is that you know how to do u sub pretty quickly. So our final answer, if I ask you to find the actual integration of arc sine, or what function's derivative would give this back to you, it's going to be x inverse sine of x minus a negative. So you want to also be careful about that. This is minus a negative, so this will be plus. And then we're going to do the square root of u, which is going to be, well, what was our u? Well, our u in this particular example was right here. So it's going to be the square root of 1 minus x squared, and then we're going to do a plus c. And that's how you're going to get the answer to that problem if you had to continue on with it. So again, if you took the derivative of this function and simplified it down, you would get the arc sine of x. So that's it for this video. In the next one, we're going to talk about what happens if this is not very easily integrated. What can we do? So I'll see you guys in the next video. Take care.